Cards are crazy. All right, guys. So what we're doing today is finishing out the review sheet. We're going over the last so many problems. And your test part 1 is tomorrow. Part 2 is Friday. So we're going to go on and look at these here. If you don't have these steps down, might be nice to have those written down, especially with the solving, just so you can look back on it and refer back to it. Okay, I'm just making sure. So as we look at these first two, 31, step number 1, is there one radical? If yes, get it by itself. If no, even them out. Since number 1 already has a radical, we just need to get it by itself. It is by itself. So we're going to put both sides to the nth power. And the nth power in this case is 2. Because since we just have that square root term on the left-hand side, the square root and square would cancel, leaving us with 2y. The right-hand side, we're going to go on and square it. We have 8 squared. 8 times 8 is 64. So we're saying that 2y is equal to 64. Step 3, are there any radicals left? No, so we don't have to worry about step 3 at all. We can go to step 4, solve for the variable. Since we just have y, we don't have y squared, we don't have y to a power, we just need to get it by itself. So we're going to divide both sides by 2. 2y divided by 2 is y. 64 divided by 2 is 32. So we're saying y is equal to 32. Now the last thing we need to do is check, because on the review sheet it said solve the equation and check your answer. We're going to need to check it. If the instruction says to check it, you need to check it. There are points assigned to checking your answer. So this here, we get the square root of 2 times 32 is equal to 8. So when I'm looking at checking and grading it for if you checked it, bare minimum, I'm going to need this. Then you can come over here and say second square root, 2 times 32. Check and see what its value is. It is 8. So it is telling me that 8 is equal to 8. We checked it. It did work, so that is our solution. So check, I would just need one showing me that you plugged it in. Just rewrite the equation out with those values, those solutions plugged in, and show me what you get when you simplified both sides. That's all you need, bare minimum. If you wanted to actually work it out, you could do that too, because that would be 2 times 32 is 64. Square root of 64 is 8. 8 is equal to 8. You just do it step by step, showing that that value, in this case, did work. Questions on 31? 32. Square root of y minus 4 plus 7 equals 15. There is indeed one radical. So we need to get it by itself first. And the first thing we can do is subtract 7 from both sides. Yes. Because we want to get that radical by itself first. So subtracting 7 will do that. Now it is completely by itself. So we're going to put both sides to the nth power. And again, since we have square roots, we're going to square both sides. On the left-hand side, that square root and square would cancel, telling us y minus 4 is equal to 8 squared. Well, 8 squared is 64. There are no radicals left, so we're going to go straight to step 4, solving for the variable. Since we just have y to the first power, we get y by itself, and it tells us that y is equal to 68. then we're going to check it, make sure it works. (68 minus 4 is 64. Square root of 64 is 8. 8 plus 7 is 15. 15 is indeed equal to 15. Done. And we could have plugged that into the calculator too. Second square root, not x root. Second square root. 68 minus 4 plus 7 is 15. It does work. Questions on 31 or 32? Questions on 33 or 34? 33. Is there one radical? Yes, so we need to get it by itself. So we'd subtract 27 from both sides. And if we do that, our 27 minus 27 becomes 0. We're not going to rewrite plus a 0. 4 minus 27 gives us negative 23. Now, as we went over in class, we know that an even root, square root, fourth root, sixth root cannot equal a negative number. At this point, I wouldn't necessarily throw it out, but it's highly unlikely. Because before we throw it out, we do need to get the radical by itself. So we're going to divide both sides by 3. Well, negative 23 does not divide by 3 evenly, so we're going to leave it as a fraction. Is the radical by itself? Yes. And we still have an even root equal to a negative number, so this isn't going to work. There's no way to take a square root and get a negative number. So this is going to be no solution. However, if I didn't notice that and I went straight to the next step, putting both sides to the nth power, squaring it, these will cancel out, telling me that 2x plus 7 is equal to negative 23 over 3 squared, 23 over 3, which is 529 over 9. We don't have an x squared term, so we just need to get x by itself. First thing I would do is subtract 7 from both sides. And again, at this point, I'd grab this, say minus 7, giving it 466 over 9. Last but not least, divide both sides by 2, telling us x is equal to 233 over 9. And then all we need to do is plug it back in and check it. And to do that, we'd have 3 times the square root of 2 times 233 over 9 plus 7 plus 27 is equal to 4. Yep. 3 square root 2 times 233, too many 3's, over 9 plus 7. That part there is 23. So we have 23 plus 27 is equal to 4. 50 is definitely not equal to 4. So that doesn't work, so it is no solution. There will not be a no solution on the test. Well, we can go on and look at 38 since we're right here. Welcome. For 34, there is one radical, so we need to get it by itself. it is by itself. So we can put both sides to the nth power. In this case, we're going to put it to the third power, because our cubed root and third power will cancel, telling us 2x minus 1 is equal to 2 cubed, or 8. Now we need to solve for x because there are no radicals left. So the first thing we're going to do is add 1 to both sides. 8 plus 1 is 9. X is still not by itself, so we're going to divide both sides by 2, telling us x is equal to 9/2 or 4.5. We can leave it in either version. We can go on and check it. The cubed root of 2 times 9/2 minus 1 is equal to 2. If we did this by hand, 2 times 9/2 is 9. 9 minus 1 is 8, and the cubed root of 8 is 2. 2 is indeed equal to 2, so it tells us 9/2 is the correct answer. Questions on this here? Why not? Let's look at 35. Do we have one radical? No, we got 2, so we need to even them out. And the main way I would even them out is I'm going to add the 9th root of 4x to both sides. If one of them is negative, when we're trying to even them out, I'm going to move it. Because by moving that negative, both sides have a positive radical on both of them. So by adding it to both sides, we get that the 9th root of 2x minus 1 is equal to the 9th root of 4x. Now we got to put both sides to the nth power. And the nth power in this case is going to be 9. Now it's nice because the only term we have on either side is the 9th root. So the 9th root of 2x minus 1 to the 9th is 2x minus 1. On the right-hand side, the 9th root of 4x to the 9th is 4x. We don't have x squared terms, so we need to get the x's on one side and by itself. So the first thing we can do is subtract 2x from both sides. Telling me negative 1 is equal to 2x. Lastly, we're going to divide both sides by 2, telling me x is equal to negative 1/2. And like we've been doing all of these so far, last thing we're going to do is check. So the 9th root of 2 times negative 1/2 minus 1 minus the 9th root of 4 times negative 1/2 is equal to 0. I'm going to go on and do this by hand. First, 2 times negative 1/2 is negative 1. We still have the minus 1. 4 times our negative 1/2 would be negative 2. Our negative 1 minus 1 is going to be negative 2. Leaving us with the 9th root of negative 2 minus the 9th root of negative 2. They are like radicals. 1 minus 1 is 0. If we plugged it in, I'd go 9th root, 2 parentheses negative 1/2, minus 1 minus the 9th root of 4 times negative 1/2, and lo and behold, it tells us it is indeed 0. Works. And you might be wondering about having a negative inside these radicals. It's fine because the index, the root we're taking, is an odd root. We can take the odd root of a negative number and get a real solution. We cannot take the odd or even root of a negative and get a real solution. Over here, let's look at 36. This still works, even though the radical is by itself, because we have an odd root. We're taking the cubed root, the third root of this here. Now we do have one root, one radical. It is by itself. So we can put both sides to the nth power, and that power is 3. And we do that because we want that third root and third power to cancel. Telling us that 10x plus 15 is equal to negative 125. Because negative 5 cubed is negative 125. Since we don't have an x squared term, we need to get x by itself. First thing we're going to do is subtract 15 from both sides. 15 minus 15 is 0, leaving us with 10x is equal to negative 140. Lastly, we're going to divide both sides by 10, telling us x is equal to negative 14. If it told us to check cube root of 10 times negative 14 plus 15 equals negative 5. Ten times negative 14 would be negative 140. Negative 140 plus 15 is negative 125. That is indeed negative 5. Negative 5 is indeed equal to negative 5. Questions on any of these so far? We can look at 37. Radical is by itself, so we're going to put both sides to the nth power. So we're going to square both sides. On the left-hand side, the square root and square would cancel. Telling us 3 minus x is equal to x minus 1 squared. Now the x minus 1 squared, we're going to have to actually multiply this out because we have two terms being subtracted. We don't have a single term. Unlike our left-hand side, that radical and square. So the first thing we have to do is our x times x, which would give us x squared. X times negative 1 would be negative x. Negative 1 times x would be negative x, and negative 1 times negative 1 is going to give us plus 1. On the right-hand side, we can combine like terms. That negative x minus x would indeed give us negative 2x. Now that we have everything simplified and kind of reduced, combined like terms, we would go to step 3. There are no radicals left. So we move straight into step 4, solving for this variable. Now, because we do have an x squared term, we need to get this equation equal to 0. First thing I can do is add x to both sides. I could have also subtracted 3 first. It doesn't matter which. Whichever one I don't do first, I have to do it next. And once I get this equation equal to 0, we get that 0 is equal to x squared minus x minus 2. Here, and all the ones on the test are going to be factorable. You are going to be able to factor it. So the first thing I would be doing is looking for a greatest common factor between these three terms. There's not one. So I'd move to 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Only factors of 2 are 1 and 2. X times negative 2 would be negative 2x. 1 times x is plus x. Negative 2x plus x, negative 2 plus 1 would indeed give us our negative 1x, negative x that we wanted. It might have looked like at a certain point that it wasn't factorable, but it is. It wouldn't have been factorable if that had been plus 2 instead of minus 2. Now we do have 2 things that multiply together to equal 0. And according to the zero product property, Either x plus 1 is equal to 0 or x minus 2. So we have to set both of those equal to 0 and solve. So for x plus 1, we would subtract 1, telling us x is equal to negative 1. For x minus 2, we would add 2, because our negative 2 plus 2 would simplify out, telling us x is equal to 2. And especially on these here where you're going to have to check. Oops, I'm not on the right page. Square root of 3 minus negative 1 is equal to negative 1 minus 1. Now I can work this out. Negative 3 minus negative 1 is the same as 3 plus 1, giving us 4. Square root of 4 is 2. Our negative 1 minus 1 would be negative 2. 2 is not equal to negative 2. So x equals negative 1 does not work. If we wanted to, we could have done this in the calculator. 3 minus negative 1, it tells us it's 2. Negative 1 minus 1, negative 2. We fill those two numbers in. We're going to do the same thing with 2. Square root of 3 minus 2 is equal to 2 minus 1. Well, 3 minus 2 is going to be 1. Square root of 1 is 1. 2 minus 1 is 1. 1 is indeed equal to 1. So our only solution for this here is x is equal to 2. And on the test, I am going to want the extraneous solution and the actual solution. I'm going to want both. Questions on that one there? Questions on 38? You feel good with 38? I think for the most part, realistically, I've covered every single one that's going to show up. If we feel good with this here, I'm not necessarily going to keep going through them because I feel at this point you feel comfortable with them. The biggest thing I would say is make sure you finish the solving homework assignments for the solving part of the test. Those assignments might be very helpful for this year. But tomorrow is part 1. Friday is part 2. If you miss either one of those, you'll have to make it up next week. Wednesday's the last day. Feel pretty